and combine all the partial results across a huge number of clusters. So as I just described, to process data on the Hadoop, you need a distributed file system. The distributed file system, if you take the case of Hadoop, it is HDFS. So HDFS, if you give a file to the HDFS, it can take it, it can split into smaller chunks and place it on various machines based on the number of machines it has, or based on number of splits it has created out of the input data. So once you have this, right, when you install Hadoop, typically you will have HDFS as well as MapReduce both, though these two are two different systems. One is a distributed file system, HDFS, and the other one is the MapReduce, which can process the data that is sitting on the HDFS. So now, taking this as the precondition that we have HDFS ready and we have put a file on the HDFS, and this has been split into n splits, 1, 2, 3, up to n. So now how MapReduce can process this data, right? So you have a MapReduce engine that comes along with the Hadoop. So now the user can write MapReduce programs using the interface, programming interface of the MapReduce. Typically it is a Java. You have a Java API, you can write the MapReduce programs. The MapReduce program typically consists of two components, two major components. One is the map component, other one is the reduce component. So far, I have given a picture of the holistic program, or the whole program together working and giving you the result, working hand in hand with the MapReduce engine. But actually, the MapReduce program consists of two major components, a map and a reduce. So this is what these two divided components is what gives the ability to combine the partial result. So we'll see how it happens. So when you develop a MapReduce program and execute it on the Hadoop cluster, what happens is the map program that you have given, this is a single program, so don't think that these are multiple programs. It's a single program. It has been deployed onto each server to run the process on the individual split. So your map program, out of your map and reduce component, your map program runs on each individual server on the individual split of the file. So now you have the partial result that is given out by the map program, the map component of your job, your Hadoop MapReduce job. So now what reduce program that we just spoke about can do is that it can receive the partial result from each of the map so that it will combine the result on the reduce side. But how do they get the data? How do reduce get the data from the maps? So that is where the MapReduce framework comes into picture, and the MapReduce framework will execute an intermediate phase called as shuffle phase. So what shuffle phase can do is that it will identify the keys, identify the relevant data in the intermediate result produced by map, and it will divide that by the number of reducers. So here also it is achieving parallelism. If you see on the map side, it is doing the parallel processing, and even on the reduce side, it can achieve the parallelizing, thereby increasing the performance, increasing the speed of your job. So it will smartly divide the intermediate result between number of reducers. So you have, let's say, 30 keys. It is possible that 10 keys will come to the first reducer, second 10 will come to the second, third 10 will come to third. Thereby, you are increasing even the reduce phase speed by 3 times, right? So on the other maps as well, the shuffle phase will take care that the same key on every mapper will reach the same reducer. Let's say you have a key apple here, okay? The MapReduce engine's shuffle phase will take care, will guarantee that the apple from this map, the apple key from this map, this map, this map will reach a single reducer. So we were talking about the split result or the partial result scattered across the cluster on various machines where the maps have run. Now, by the shuffle phase, we have guaranteed, or the MapReduce framework has guaranteed that the similar keys will reach the same reducer. Now it is as simple as applying your the metric. It could be addition, it could be average, or it could be you may want to apply a very complex statistical function on that particular key and the corresponding values. So the MapReduce shuffle phase is what makes this possible. That executing on the various machines parallelly and then be able to get an integrated result. So this is what goes on in the background of the MapReduce execution. A map phase, which will go to a shuffle phase and then reduce phase. And once the reduce phase or the reducers on which on the machines where these are running will write the data out. Either it could be to the distributed file system, or it could be to any other file system of your preference. It could work with S3, it will work with various other file systems as well. It's not restricted to the HDFS. Right? So this is the brief working of the MapReduce, how exactly it works. Right? So, but how this is made possible? So I'm talking about MapReduce framework, shuffle phase, and then someone launching this your map task or reduce task without your interference. You are just giving the map program and the reduce program to the MapReduce engine, right? And then it is taking care of all these things. You are free of all these burdens, shuffling and where which program is running, where your file splits are sitting. You don't need to bother about all those things. But how is this made? It is made through the MapReduce, the framework of the Hadoop. It has the processes, it has the daemons running. When you say your MapReduce is running, you will have all these pieces running on various machines which will coordinate, which will take your job, which will launch the maps, reducers, right? If you see the MapReduce of the Hadoop, you have the job tracker